Welcome to Brain Vision.
So again, we have a beam laying on a ground, and we're told to assume that the force from the ground is distributed uniformly. In this case, we have 3-point loads. And so we can figure out, we're actually given values in this case, so we can figure out that the force down here is 2 kips per foot. And so we take cuts in between all of these loads, and we start with a zero shear here, and we better end up with a zero shear here. So we come here and we wind up increasing at a rate of 2 kips per feet. And then this load here is 6, so we drop down 6 units, and so we're at -2. And then we start back up, increasing with the slope of 2 kips per foot. And then this middle load is 12, so we drop down to 12 units to -6. And then we again start climbing back up at 2 kips per foot. And then we drop back down here by 6 units, and again we start climbing back and we get to 0. So it turns out our maximum occurs right at this load, whether it basically jumps from 6 to -6 is the shear force on each side of this load here. So the bending moments, we again have quadratic functions in each of these regions, and I wrote those out here. Again, basically integrating these curves, and then we have to have continuity here. So we have x squared here, and then 12 minus 6x plus x squared here. So we're always going to have x squared because this had a slope of 2, so when we integrate that, we're going to get x squared. And so now we have 84 minus 18x plus x squared for this curve, and then 12x minus 12 quantity squared for this curve here. And so now we can see that the maximum bending moment occurs right at the middle here again. And again we can see we have this symmetry. And now we have the absolute value, value of that is 12